All right, we're now going on to properties of logarithmic functions as additional exercises. And referring you to your booklets, we'll start off with matching, which is sort of nice. Again, hopefully you might have looked at this on your own. Otherwise, we're going to give you the answers, keeping in mind the answers are toward the back of the booklet. So here we have log base A of mn. Remember, this is times, so it will be C. Now this is log A of m raised to the p power. The p, remember, just goes in front over there, and that looks like D. Now for number 3, we're looking for that rule about adding or subtracting. Here this was adding. When we are dividing, we're going to be subtracting. So this will be letter E. And then the last thing we did in both the text and the PowerPoint, we said when these were both the same letter, this in a sense became 1. So that would be K equals K. So that's going to be letter A. And I think I just gave this one away. This we said was 1. And that's going to be F. And there's only one left. And the log A, where it's going to be 1, what did we say is the power that gives us a 1? And we said that was 0. So that's going to be B. And hopefully I got those all right. Yes, I did. All right, let's continue on to some examples now. And we'll write these out as you should as well. Express as equivalent expressions, that is a sum of logarithms. Well, here they're not asking us to work it, just to write it. So it'll be log base 2 of 4. And since this is multiplication, plus log base 2 of 128. And that's all they're asking. Again, they're not asking us to solve it, just to write an equivalent expression. All right, here it's going to be log base B of 5 plus log base B of X plus log base B of Y. Okay, again, once you know what it's about, it makes it a lot easier. Now, in this one, they want us to sort of revert from what we had before to what it might have come from, a single logarithm. So it will be log base A, then we put parentheses, and it would be 10 times 9. Now you could leave it this way theoretically, but you can actually do this multiplication. Then you don't need the parentheses. All right, now this one, again, it will be log base y, and then parentheses, a plus, no, not plus, times, I should say, because this is multiplication, and we could just write it without any times symbol there. Now express as an individual expression that is a product. Okay, now here we see an exponent. So we're using the rule of powers to powers. So we have to put that exponent up front as 6 log. Our base is a, t. So this is 6 times the log base a of t. And here our exponent is a -5. So -5 log base c of h. So I think these are a little easier than things we were doing before, as long as you know the rules. Number 13. Now they want us to write this as an equivalent expression that is a difference of two logarithms. So here this will be log of 3, and this is going to be on top. So base 3 of 10 minus, because of our denominator here, log base 3 of 13. And this will be log base t of u minus log base t of v. Now remember, if you have something like this, it can revert to this, which is what they're asking us to do here. So I actually put a little mark there that I didn't want. Okay, so this is going to be log of log base a, and then we're just going to set up a little division bar there. 25 on top, 11 on the bottom. And the same thing here. Log, this is base b now, and then a division bar, 48 over 4. Now, again, since they're giving us the numbers 48 and 4, you could simplify this, but in this case, you do not simplify, you leave it like this. Okay, now they're asking us to express as an equivalent expression using the individual logarithms of these. So it's log base b of w plus log base b of x plus log base b of y plus log base b of z. All right, let's go on. Now notice we have some negative exponents here. So this one, as we write it, so let's go on here. So we have a negative 2 exponent. So this will be a negative 2 log of base a to x. Now this one will just be plus, no exponent, just the 1. So this will be plus log base a of y. And this one has a 3 in front of it. Or I should say, because of the 3 exponent has a 3 in front, log base a of z. So once again, when they have exponents, you put those numbers in front of the log. All right, let's do this one. So it's going to be log base a, and because of the 3 by the w, we have to put a 3 there. 3 log of w plus, and here there's just a 1, so nothing out in front, log base a of x. Now, both of these are down in the denominator. I could put a negative sign and then parentheses. In fact, let's do it that way. Negative, because both of these are going to be in the denominator. And this first one is just plain log base a of y. And now since I have this negative sign out here, I can put a plus. And then this is going to be, because it has an exponent of 2, I have to put that out in front. 2 log base a of z. Now if I remove the parentheses, which I worked it the other way before, this in a sense will become a negative, and this that used to be a positive becomes a negative. So now I can take my eraser and erase my parenthesis, erase this sign here, and this is going to be a negative, and this is a negative. So I could have just put the negative there and the other negative there. I just wanted to show you one of the ways they were showing in our textbook. Okay, let's raise it up for 20. Be sure we have plenty of room here. Now, for this one, as you write it, you want to convert all of this to its fractional exponential form. So sort of an intermediate step would be log of log base a. All of this now goes in a parenthesis. That's to the 1/4 power. And then you just have x to the 20th, y to the 4th, a to the 5th, z to the 11th, which will then become, and I'll write it over here. Now, since all of this is to the 1/4, I'm going to put the 1/4 out here. and then a big parenthesis, that 1/4, which is the exponent of the whole thing, applies to everything in here as well. So this then becomes, and there's a 20 by this one, so it's 20 log base A of x plus 4, the exponent of the y, log base A of y. Now for these, I'm just going to use a negative and a negative, but this will be a -5 for this exponent, log base A of A, and this will also be a negative, and there's an 11 log base A of C. Wow. Again, it looked a little complicated, but hopefully following through the procedure, you get to see how it works. All right, express as an equivalent expression that is a single logarithm, and if possible, simplify. So our base here, let me look at this one a little more carefully because I see, okay, there's our base is x. So we have a 5 that's going to be on this one. We have a 4 that's going to be on the Q here. So I'm just modifying this a little bit. So it becomes log, and since they're both positive, log base x of p to the 5th power q to the 4th power. Okay. And for this one, again, they get a little tricky here. So I had a call come in. I was interrupted there for a moment. So we're just putting this into its single unit form, so to speak. Now this negative indicates it's in the denominator. And notice an interesting thing happens here. What is the third root of t cubed? And I'm going to erase that because the answer is just t. And what happens here? You can actually simplify. So this will equal log base b of bt, because this one comes up here and cancels out. Now there might be another way to do this, but I think that's the easiest way. So easiest way works with me. Let's go on. All right, number 24. Now this one looks a little tedious, but again, they're getting more challenging, but let's work it as best we can. So here we have log base A of 3y times, and I'm going to take a moment to organize. Okay, as we look at this then, there's our log base A. We write this. This plus turns to a times here. And then it's going to be 5, the log of this. And this is going to be to the 5th also. And that. But notice we have y times y here. So we have to do a little more simplification. Now this is going to be a 3. Now this is y to the first, y to the fifth. This makes this y to the sixth. And this is over z to the fifth. Okay, now it makes sense. All right, number 24, what do we have here? So this is going to be log A, and it's of this, 5x minus 5, all over x squared minus 1. Now, it looks like they want us to do a little factoring there. So let's factor that. Oh, we haven't done factoring in a long time. So we can take a 5 out of there, and we get x minus 1. And we can factor this into its conjugates, x plus 1, x minus 1. And now what we can do is cancel out these common factors. So there's our final answer right here. And that checks with what's in our booklet. Oh, some of these get to be a little challenging. And then now they're giving us, with this given, use the properties of logarithms to calculate numerical values for each of the following. Okay, well, let me work these out a little bit for you. And the tape is getting a little long. And you might try them first, and then I'll show you the answers. Okay, let's move on these. Number 25, log base A of 10. Remember, 10 is 2 times 5. We had to tease that 10 apart so we can use these values up here. So now we just have to add these values together. 2, the value of 2 plus the value of 5 is this. Now here it's already a 5 and a 2, but we know we have to subtract the 2. So it'll be this minus that gives us this answer. And here the tricky part is the log base A of 1 is actually a 0. 0 minus whatever this 2 would be. So 0 minus this is just minus that. And then we have log base A of 7. Is there any way to get a 7 as factors of a 2 and a 5? No. 10, yes, but not the sum, even though it looks like sum here. Remember, this is multiplication. So this one cannot be found. And let's go on. Number 26. Well, at least we have some easy ones here. Notice B of B is 1, so this is 19. E and E is 1, so this is just P. Now, use the properties of logarithms to find each of the following. Well, as we look at this, this is going to be log base 2. 64, you recall, is 3. No, let's go 4. 4 to the third power plus log base 2. 16 is 4 to the second power. So we can just use old-fashioned techniques. This is going to become 4 to the 5th power, which is, well, that is correct. But notice our base that they want here is 2. So this would actually be 2 to the 10th power. So that's the answer they're giving us. So this was going to be log, I should probably look at the answers before I do these. This is going to be 2 to the 6th power, and this is going to be times 2 to the 4th power, right? 2 to the 6th is 64, 2 to the 4th is 16, and they're looking for a 10 out of there. Okay, and let's check this one out. Now this is the 5th power. All right, so this is 5 to the 4th divided by 5 to the 2nd. So this is going to be 5 to the 2nd. So the answer they're looking for there is 2. Well, all right, we had a little bit of a snag there toward the end, but I think we picked up on it. And again, your practice and your quiz me's to earn mastery as you prepare for your test.